MCQ number 1.
Delta.
KCN is nucleophilic substitution and HCN is nucleophilic addition. Yes, that is right. All right, number 2. Let's zoom out a little bit to see more of it.
Alpha.
Perfect. 3.
Beta.
Good. And which one is going to give the yellow precipitate?
Yellow precipitate.
Yes. If beta is correct, one of them is going to give a yellow precipitate. Which one will?
Yeah, CH3, the compound T.
Compound T. Good. Number 4.
Delta.
Good. And of course, delta is the answer because it's a stereoisomer. Now, what I want you to do is to go ahead and point out which carbon is chiral. Of course, there is a chiral carbon. That's why you are able to say it like that. Good. So why not E? It could have stereoisomers, and that could have been because of cis trans isomerism.
There was no chiral center. Yeah. And
But it can have cis trans isomerism, can it?
no, because on one side this carbon has two methyl, same groups are attached to this carbon
Good.
double bond.
Well done. Well done. All right. So 5.
Delta.
And why is that? First, that is correct. Good. Why?
Yeah, 1 mole should give 2 moles of trihydromethane because there's two of the CH3 C
And
double
what
bond
about
O
bond?
groups. And oxidation of ketone, I don't think
Well done.
possible.
6.
Yeah. Alpha.
That is correct. Good. I'm going to scroll it down. 7. I mean, step away for a minute. Take your time to do
Yeah,
7,
sure.
8, and 9 by then. Perfect. I'm back.
All right, I'm done with the 7.
And the
Alpha.
answer to 7 is? Did you say alpha?
Yeah, alpha, yeah. Ethanol.
2,4 positive, 7 positive. Perfect. Okay, 8.
Eight is alpha.
Good. Move on. 9.
Beta.
Alright, great. And why?
Because in ethanol there's the CH3 and then carbon double bond O. So it will give the positive result with the, it will give a yellow precipitate, but propanol does not have that CH3 carbon double bond O. So it won't give
Right.
the yellow precipitate.
Good. 10.
So in beta and Charlie, chains are not complete or what?
Yeah, they are like that. It's not that the structures are incomplete, and it's not even the monogram interfering. They are like that. This is C double bond O, and
All
that
right.
is not connected to this. This is CH, and H is not connected to it, of course.
All right.
This should be easy.
Yeah, I'm just figuring out between Charlie and Delta.
Okay, take your time.
Delta?
Perfect. And why do you think delta is correct?
It's secondary alcohol, and secondary alcohols are oxidized to ketones.
Yes, good.
So with the tolerance ratio no change, and it will go to precipitate.
Okay, good. Now, if you work your way back for this specific one, like you start off with the test, it's not an aldehyde because toluene is negative. It is a ketone because 2,4-D pH is positive, and it has been oxidized. So ketones get to that form because of the oxidation of secondary alcohols. There you go. You can literally jump to D when you think it that
Yeah.
way. So moving on, 11.
Beta?
That's not right.
It's not right?
No. Think again.
Aldehydes get reduced to primary alcohols, right?
Yes.
And ketones to secondary alcohol.
Right.
So that should be beta then. Aldehyde will be.
Aldehyde is first oxidized, then reduced. Don't you think nothing happened
Okay, so
upon?
aldehyde gets converted to carboxylic acid.
Right.
And okay, then it can't be reduced by NaBH4, only by LaH4. So alpha.
Alpha. Good. Now you got to the point.
All right,
Okay.
all right.
Moving on. 12.
Alpha.
Perfect. Moving on.
Thirteen is alpha as well.
That was easy. 14.
So if it's decolorizing acidified potassium manganate, what does that indicate?
You said if it's decolorizing potassium, acidified potassium manganate 7, then what?
What does that indicate? Like, what's that telling us?
That it can be oxidized.
It can be oxidized.
Right.
All right. Alpha.
Perfect. 15.
delta.
Show me the working and prove what butanone forms and where is the chiral carbon exactly. Let's give you some empty space. You're correct.
All right.
First, you're right.
I'll draw
Go ahead and show me the working. What is the product?
Yeah, I'll draw the product out.
Well
Yeah, this
done.
carbon is the chiral. Yeah.
Well done. Because it has alcohol, methyl, ethyl, and hydrogen. 4 different
Right.
groups. Good.
Yes.
And what kind of alcohol is that?
Secondary.
Secondary. Good. 16. That's a little tricky, but you can do it if you go with the hints.
Yeah, I'm doing the acidification. So I'm getting C4H7O2 as the empirical formula.
Okay.
This is the Q which I got. Mm. And at the rest, hydrogen is attached.
Understandable. That's exactly what Q is supposed to be.
And then we'll have another molecule of Q. So we'll remove the OH from the carboxylic acid and H from the OH, right?
Right. But remember, R should have two ester function groups, not one.
Yeah, two ester functional groups, yeah. So
how would you combine them both? That's the tricky part.
yeah. Mhm. If we remove this OH and this H from here, then
What if I take you out of jeopardy?
I'm sorry?
What if I take you out of the whole difficulty you're facing?
Yeah, sure.
Now, let me tell you something which might come as a problem for a person to change in himself or herself, but that definitely helps. Remember, in the MCQ paper, it's not about figuring out what the exact stuff is, It's all about figuring the answer correctly. And that might be done without figuring out the whole thing. Now, you're stuck over here. Now, what's getting you stuck is that you're not able to find your final compound or what it would look like. Now, let me tell you, you don't need to. Now, the clever part over here, which you can play to save your time, is that simply take H out of this, take OH out of here, H out of here, OH out of here, H out of here. So what do you do? In the entire two formulas, what do? You subtract two water molecules. That's it. So what are you left with?
Yeah.
Let's count. You have 6 carbon atom. You have how many
Right.
oxygen? You have a total of 4 oxygen atoms. And count your hydrogens. You have 3 over here, 1 over here, 3 over here, 1 over here. And you have a total of 8 hydrogen atoms. Because these hydrogen atoms will go towards, of course, water making. None of the hydrogens of carboxylic or alcohol will be there. So you do not need to figure out what the compound would look like. You only need its empirical formula. And that's what sometimes take the most of the time for the students, is that they sit there and they figure out the stuff. Did the examiner ask you to do so? No. A clever person would never waste their time on this stuff. They would simply take their answer out, move to the next question, and they'll think about it later on whenever required, or if the curiosity allows. If it doesn't, you're still sure you have done it right. Figuring out what the compound would look like will not make you a chemist in overnight, or will not do you any good. Yeah, you might need to satisfy your curiosity later, but that you can do later. So don't fall for the trap of forming the whole compounds. For organic chemistry, this can be a big wastage of time. Just work your way out, find your answer, and that's good enough. And this fact is pretty good, because this way you can calculate the molecule and the empirical formula without getting to know the whole structure.
Yeah.
Since you have this information, there are 2 ester functional groups, which means nothing is left that can react with sodium. Now, you already know alcohols react with sodium as well as carboxylic acids. If there is no alcohol or no carboxylic acids hydrogen left, that means we take out this, 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 and this. This clarified for me that only these 4 on each of the carbon hydrogen that are left. That's why I came up with this 8 so easily.
Yeah, I got it now.
Good, good. Let's move on. And be clever. Please be wise. Don't fall for the obvious traps. Of course, you're going to need the whole question. I need to zoom out.
It's fine. I just need to see the first 3 of them. Yeah. Beta.
Sorry, I kept talking while mute. Let me see. So we have A, B, C, D. D is this. Definitely not the answer. Yeah, beta. Beta is correct. Good. 18. How much time do you have left in iftar?
I'm sorry?
How much time do you have left in iftar?
13 minutes. 13.
3013.
1313.
Is it alright if you get up just a few minutes before?
Yeah, it's fine.
let me know when we need to end the class and end it right then
All
and
right,
there.
sir. All right. This would be alpha 18.
Perfect. 19. Is that a repetition? No, it isn't.
Delta.
Perfect. 20.
Sir, can you solve this one? I'm not getting the idea.
20. So 3-methyl
Yeah.
butanone is treated with alkyl aqueous iodine. 3-methyl butanone. The mixture of products is then acidified. Which compound is present in the final mixture of products? 3-methyl butanoic acid, methyl propanoic acid, and butanoic acid. Okay, so that's 3. They never gave the number of butanone, but since it's 3-methyl, so I'm assuming there's 2 over here. Since it's methyl ketone, so yes, it would react. It would then give us CH3COONA, which, if acidified, which means it's hydrolyzed. Wait a second. No, that's not right. Out of this part, sorry, I actually made a mistake. Out of this part, we do understand that out of this portion, this bond is broken down. This is converted into CHI3,
CHI3.
and this part is converted into CCCOO negative, Na positive, and this would be like this, of course. So we have this then this would further be replaced with H because there is acidification. Means
Okay.
this is methyl, this is prop. I
So
guess C.
methyl propanoic acid.
Yes,
All right.
methyl propanoic acid.
All right. I get it. Yeah. That makes sense. Okay.
21.
I think we can stop here, sir. We'll go into
Okay,
20,
sure. Allah Hafiz, beta.
Allah Hafiz, sir.